Hello and good afternoon from Cologne in Germany. Just welcome from Fernando Italian English to German English. David, many thanks for introducing me. You are doing really great job in those 3 days. But also special thanks to Miranda for a great support during the last time. For me, it's the first time being by ICLEW, and I really enjoyed it. On this afternoon, I'd like to present some activities and the results of a new education approach. It covers many of terms I already heard in this conference, terms like Industry 4.0, learning by doing, digital twins, and so on. Wait, something is always okay. First, I'm going to give you some boring background information why automation is so important is today as training for engineers, and where can we find and use automation. The main part of the presentation, I describe Industry 4.0 architecture for remote education, especially useful for COVID-19 time, and I developed digital twin for students' exercises. Lastly, I will finish with a view to future research efforts and the area of higher education before I end this with a video demonstration. So, why is automation so important today? When we started to build the large plants here on the left side of this slide, in the beginning, the cost of mechanical parts were over 90%. And the cost for electrical parts, automation parts, was less than 10%. But due to declining of prices in semiconductors and processor technology, more and more electrical parts started to be integrated into industrial machines and plants. So when we would build the same plant today, the situation is quite opposite. The biggest are automation costs today, more than 60%. And they are divided to software license, cost for hardware devices, and cost for engineering. Engineering means people people also like our students, which we teach. So that I can say that we set some goals, some objectives like this, creation of a concept for distributed control systems. We started to develop some new software tools for monitoring of students' progress during the teaching time. But let's see now how the automation is integrated in a program of a common mechanical engineering study. On the right side, we have usually basic modules like mathematics, physics, informatics, logistics. And on the left side are usually the modules like design, materials, mechanics, all parts which can have to be manufacturing, measurement and control. And if we focus a little bit more on those modules, they all deal with mechanical parts, and automation as discipline is doing just with electrical and electronical parts. When the students have graduated, they get work in different industry, starting a specialist from as a specialist for compact machines, complex machines, large plants, infrastructure, and in some of some of other application like woodworking machines, baker machines, car washing machines, and so on. But it's very important to educate them. It's very important to educate the students in those technologies shown here. And it's very important to prepare them also for the jobs that don't exist yet, but will be created in the nearly future in several segments. From the existing concepts, the technologies here in the middle of the slide, we have development of working stations for training, which contains almost 90% of all automation used technologies on the market. But let's start now. Just let's take a look on what education concepts are recently used on universities. The currently most widespread model for knowledge transfer, also on European universities, is in some cases still by passive lectures, where due to theoretical inputs, knowledge transfer happen due informations. However, such knowledge transfer through theoretical input always suffer from a very low recall rate, which is after 3 months less about 10%. This survey is a study from the company IBM. And applied-oriented teaching with the support of practical exercises, simulation, group works, can improve this recall rate until 32%. But we have still students, but the number of dropouts is still too high. One of the main reasons for the dropouts after this approach is a high level of abstraction in the transfer from knowledge, especially in mechatronics modules. But recently better results can be achieved when we teach, like also several times during this conference mentioned, by training, learning by doing on real machines. Also, if we make the training of the students on real machine, real or virtual environment, and according to this survey, the recall rate can be exceeded to 65% after 3 months, and which can also significantly lead to better learning outcomes of the students' results. For this purpose, we developed a working station a working station which can active experience and can make the system learning by doing. Such an approach can make the level of abstraction of complex programming tasks much more comprehensible, even when the students work in team. I'm not going to explain all technologies deeply in detail on this point, but just to mention, we choose the components for data acquisition, sensor actuators, push buttons, monitoring and control of machine and plants with a human-machine interface, data processing with a PLC, drives and motion with with industrial communication like field buses and Ethernet, industrial Ethernet. A very important part of education is involved with energy efficiency, where the students can measure consumption of energy resources on devices, and they can analyze and find the best recommendation how to save energy. The main objective of this is to sensibilize the students for efficiently behavior with electrical energy. Also, in order to increase motivation the students for sometimes boring topics, we developed also some exercises and trainings with smartphones and tablets, so that the students can talk with the machines and plan with a machine and plan or process with the smartphone or tablet. For this issue, we developed an app, and the students can make the monitoring of the process, or get emails or any text messages. And but at the end also safety and security is also quite important in this matter. At the present time, due COVID-19 pandemic, many lectures have to migrate to internet teaching. In most cases, e-learning on digital tools are used to continue online courses like in Zoom, WebEx, Adobe Connect, just to replace classroom teaching. But the most current approaches are limited just to lecture or theoretical exercises. At the moment, there are hardly no universities that can offer really appropriate practical exercises with high practical relevance. This slide explains how the practical exercise can be carried out remotely via internet. The students access to the working station from anywhere, from anytime, over a proxy server. And here the first step is to check the username and password, and then they are going to be allocated to appropriate stations. And they can work from at home and make the programming of the units, make download of the units, and to control their work. So on each station, working station, as like I saw here one working station, and we built 20 of those working stations, 20 in one room, and of each working station usually in present work 2 people, but if we work online, one student for the same time. And for each working station, we provided 10 IP global addresses. And so whole laboratory has 200 global IP addresses. Student access to these stations can perform their tasks, and tasks are to programming PLC, drives, HMI, to make download, and just to check their results. They are very different skills and very different before they came to us. We talk here about diversity. Some students work very fast, are good skilled, but some and understand well and finish their task earlier. But some students need more time to finish it. So in order to optimize availability, we developed also automatically allocation of units. If the student N is working at home and he is finished with his programming, then he connect to a server, and on a server he is visible of a station is free or already connected or busy. So on this way he can choose the first free station, he can test his programs and validate the programs, and if he's finished, he can leave this station and make this station free for the next student. So on this way, we can work with end users, and end users have access to 20 working stations. So on this way, we increase availability of this station. This is an overview. This is just example from a student at home. What is doing the student from at home? On the left side is so it's a software environment, which in this software environment, the student must programming devices. Devices are from industry machines here, and those small windows are small programs in C language or graphic programming. And if student is finished with his programming of this task, he make the access to these devices and can make download of his whole project. Another side, also the task of students are also to develop so screens for human machine interface, screens like you have on your smartphone. And the students develop those screens, and in our run timer, he can also check the correctness of his programming. He can now start this motor, or can start this motor, or can start the changing of light on this unit. He can also push out here pneumatic piston, and with these human machine interface and run timer, he's able to check his results of the program. Okay, until now it's everything. All the first 9 slides are very related to Internet of Things in education. But the next slide is really something what has to do with this paper for this conference. We also have achieved the highest level of digitalization education. For this purpose, we designed a digital twin of a working station, a digital twin, and we want to be able that the students are able. We want to have that the students are able to check their programs also on virtual models. It would make a big advantages. In this case, several such CAD models can be stored on a server, and the student make just access to virtual model, and some university must not do so big investment like this here. How it works, I'm going to show it in video in following on this presentation. But just let me say what technology are used in order to develop this. On the right side, it's a CAD model from Siemens NX. It's a CAD model, and with this tool, we developed a simulation model which can communicate via OPC server, via OPC URI interface, and in video, what I'm going to show later is we work like hardware in the loop. Hardware in the loop means the PLC is hardware, but equipment is virtually. there is also possible to work like software in the loop. In this case, it would be also simulated PLC, which can simulate this CAD model. In this case, we will talk about software in loop as also, of course, possible. We as additionally feature, just to be in and according to the state of the art, we implemented this developed virtual model. We implement this digital twin or CAD model also to Oculus Quest virtual reality glasses. Previous we implement this CAD model and read a small Unity, also this gamer software Unity, a small application in order to the student can also give commands to these units also over VR glasses. Okay, I conclude because before I start with the videos. The first experience we made is the students, it lead to a high acceptance by students, the fun by so those technical issues is very high, very good results by examination, good skilled students also for design of wall automation solutions. The situation of laboratory is on this picture below. And those are 20 stations which are now remotely accessible and for which we have also digital twins. Advantage of this concept is that we can also validate research projects and in these Internet of Things capabilities, we can share these resources with other universities. In Europe, we have also experience with sharing with university in Berlin, with a university in Turkey, with a university in Kenya. And also, there is also some need for research, further research. We are working also on scheduling tools, booking services, and a big issue is to develop artificial intelligence programs which can monitoring the progress of the student during a long term, about 2-3 months. You can see on this video now. On the right side is this digital twin of one real station. The student is just put this piston out, and the second piston here, and the student are going now to put some commands for this red light here. What I want to say, we have a real model on the left side, and we have a virtual model. On real model and virtual model is controlled by this PLC hardware in the loop. So it's not easy thing because we are now coming to this CAD model from a C program. This C program is quite complicated. Also, that means if we work in this room, 2 students are sending here and can programming this real working station. And you can see now that also virtual model is everything doing what also a real model is doing. So big advantage is to say, okay, we have a good enough of those models, we can forget all equipment and save the money, and in the future to work really digitally. That is this is our part to increase some digitalization concept in education. So okay, when this movie is just okay. Yeah, the movie, the students get in previous time some exercises, and they solve those exercises, and put it in the PLC, and they can see our results. Everything is moving, everything is changing, and a big advantage is that they are learning by doing. Learning, they feel what is standing in the code of program, and they are, yeah. Okay, I think you can stop now the program. It's there is also a second video, but I don't know if we have enough time. With virtual reality glasses, and with virtual reality glasses, the student is able to now to change these commands of this light, and now he's going to start this motor below here, and the motor is going to rotate, and then he's going to put some other commands on this pneumatic piston or on this motion unit. So in on this virtual reality working station can work further. Okay.
Okay, seemed like a good, I think we were just about to stop. So thanks so much, Hasan, for your presentation, and the videos were really, really interesting to watch, and we enjoyed that, and especially the virtual reality and the learning by doing and all the concepts that we've been talking about for 3 days. Those are great examples. Thanks for sharing those with us, and we hope to see you again at a future conference.